Yes, an object can move with constant velocity when the net force is zero. How? Today we are going to talk about Newton's first law of motion. It says a body stays at rest or moves with constant velocity unless there is a resultant force acted on it. The first part of the law is very easy to understand. Every teacher uses the example of a book on the table. We know that it's at rest. There are two forces act on it. The weight, downward, and the contact or normal force, upward. They are balanced and the object, the book, stays at rest. So yeah, if your car is at stationary and it's not moving, that means these two forces acting on it, they are equal and balanced out. Most students have a little difficult time to understand the second part of the law. The object moves with constant velocity when the net force is zero. Whenever I draw this diagram for students, they understand that yes, the resultant force is zero, but most of them, they say the car stops. So it seems that the students have a little difficulty understanding uniform motion. Here's an example to clear it up. Imagine you're in a perfect car in a perfect road. So you cannot hear the car's engine and the road doesn't have any speed bump. Now, if you close your eyes, you cannot tell that the car is moving. That's the state that we are talking about, an object moving with constant velocity. The resultant force is zero. It doesn't mean that there is no force acting on the car. There are forces, the weight, the contact force, the engine forward force, and the friction or resistive force. But all of these forces, they cancel out and they're balanced with each other, and you have zero net force. So you would feel the same when you are in a perfect car with constant velocity and if the car was at rest or stationary. That's when the net force or resultant force is zero. One more thing. Sometimes they refer Newton's first law as inertia. Inertia is like laziness. That means resistance to the change. And mass of the object is related to inertia. The more mass the object has, it's more difficult for you to make it move. Or when it's moving, make it stop. The smaller mass, it's easier to start moving or make it stop. Now, what happens if you have a net force? That means the forces are not balanced. That goes for the Newton's second law of motion, and that's for another video. Remember to add important point to your physics notes. And in exam paper, look for keywords when you're solving questions, like constant speed in the straight line, or constant velocity, or even equilibrium, resultant force zero, net force zero. All of these are pointing to the Newton's first law. Let's have a quick quiz, only 2 questions. A car moves at constant speed on a straight road. What is the resultant force? Of course, is equal to zero. Which statement best describes the inertia of an object? Yes, the resistance of the object to a change in motion. If you like this video, please hit the like button and subscribe to the channel. See you in the next one.